Myself, Ketan Patel, from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari, Electrical Engineering Department. My subject name is Sub-Testing and Commissioning of Electrical Equipments, 4th year, 8th semester. And chapter is Testing of Transformer, Plant and Equipments. Okay. Now syllabus content. First is auto transformer and its general informations. Second one is steps of two transformer in parallel. Third one is process of troubles and failures of core of power transformers. Fourth one is causes of troubles and failure of power transformer. And fifth is procedure of filling oil in transformer. Okay, now first theory is auto transformer and its general informations. Okay, this is the device of auto transformer. Okay, this is a circuit diagram of auto transformer. Here it is step up and here it is step down transformer. This is the only one coil is used in auto transformer. Okay, this is a number of tappings. This is V1 voltage and second primary voltage and secondary is V2. Okay, and this points is vary from this way. Okay, this is the number of turns NSE and this is number of turns NC. Okay, then this is a step down type transformer. Okay, V1 voltage and V2 voltage is this. Okay, now what is auto transformer? Auto transformer, in auto transformer single winding is used for primary and secondary circuits. The voltage ampere or volt ampere of primary winding is equal to volt ampere of secondary windings. Since the same winding is used for primary and secondary winding, auto transformer require less material for the same output than the required by a two winding transformer. We can also say that for same amount of material in both, the output voltage of auto transformer will be higher than a two winding transformer. Auto transformer reading is two winding transformer rating into 1 upon 1 minus 1 upon R, where R means ratio of high voltage to low voltage of transformer. Okay. Now, what are the limitations of auto transformer? First is low impedance, high short circuit currents for short circuit on secondary side. Okay. In case of auto transformer, if a section of winding common to primary and secondary is open, full primary voltage will come across secondary, resulting in higher voltage on secondary and danger for accidents. Auto transformer for three-phase system are always in form of single three-phase unit. Okay, so there three single-phase auto transformer are very rarely used because of due to their low efficiency and difficulty in parallel operations. Okay, now its application is first is single-phase auto transfer for starting synchronous motor and induction motors. Second is variable auto transformer. Third one is power auto transformers. Okay. Now, what are the essential requirements for parallel operation of two or more power transformer? First is polarity should be same. Second is voltage ratio should be same. Third one is percentage impedance should be same. Okay. The phase rotation should be same. RYB like. Okay. Then the vector diagram and the phase displacement should be same. Okay. As example, YD1, dy1, etc. Okay. Now next is why voltage ratio the same for parallel operations. Now if its voltage ratio are not identical for the same primary voltage, the secondary would be different. Thus the different secondary voltage would result circulating current within the second circuits and heating of transformer even on no load. Okay. Now next question is it essential to have same rated kVA for two transformers for parallel operations? The answer is no, because two transformers need not be same kVA capacity for parallel, but their percentage impedance should be nearly equal. If percentage impedance are equal, the loading of this transformer would be proportional to their kVA rating. If percentage impedance are different, the load sharing will not be proportional to kVA ratings, as the percentage impedance cannot be exactly equal. It is preferable to operate transformer of the same rating in parallel. As a general rule, ratio of kVA ratings of transformer operating in parallel should be within 3:1. Okay. Now, what is the phase sequence and how it is changed? The phase sequence refers to cyclic order in which the voltage waves of three phases rise to peak values like R, Y, and B. A small indicating instrument or phase sequence tester is used for testing phase sequence. If any two of the terminals are interchanged, the phase sequence becomes RYB instead of RYB is RBY. So the phase sequence RBY is reverse of the phase sequence of RYB. The direction of rotation of three-phase induction motor depends upon the phase sequence of the supply connections. Okay, so these are the all basics details of auto transformers. Now next, steps of two transformer in parallel. Okay. Now, procedure of checks and steps in connecting the two transformer in parallel. Okay, this is transformer A and this is transformer B. Okay, primary winding and secondary winding. Primary winding first terminal is connected to secondary first terminals, and secondary terminals is connected to second transformer secondary connection. Then this secondary winding sides, the secondary windings is connected with the load. Okay, and this secondary windings first terminal is connected to first transformer first terminals, and second terminal is connected to first transformer second terminal. Okay, so this is a supply V1, this is a load side VL. Okay, this is currents IA and IB. Okay, so two transformers are in parallel operations. So these are the basics importance points. Like first is study nameplates of each transformer is very important. Then second is confirm whether the polarity, okay, transformer polarity, voltage ratio, vector diagram, vector group, terminal markings, kVA ratings, percentage impedance of both the transformer are acceptable for parallel operations. If not, do not connect. Okay, because they are the parallel operations conditions. Third one is connect the primary terminals of each transformer corresponding to bus bar as follow. Like a first R bus bar, primary transformer X is capital A, then primary of transformer Y. Okay, and transformer A and transformer B both connected. Three-phase transformer is capital A, then it is capital A. In R Y phase, capital B, both transformer capital B, and B phase, both transformer connected in C and C. Connect the second terminals of the transformer A and B is small r Y B bus bars. Okay, so A to A likewise. Next is measure voltage between the secondary terminal of transformer. Okay, Y corresponding to bus bar. Voltage between terminals B and bus bar Y. Terminal C, bus bar B. If these voltages are 0, make permanent connections. If these voltages are of twice, the phase value cross connected as follows. After measurement as 0. Okay. B of transformer Y to bus bar B, C of transformer Y to bus bar Y. Okay. Now, what is the safety precautions to be taken while commissioning and maintaining of transformers? First is routine daily inspections, routine monthly inspections, routine weekly inspections, quarterly inspections, annual inspections, and unscheduled maintenance. Okay. In transformers, again, first importance points is, what is the cause of overheating of transformers and how it can be avoided? The answer is, the overheating is caused by overloading or by failure of cooling system. Overheating caused by reduction in life. In case of overheating, the transformer should be switched off from service immediately, but cooling fans, cooling water should be continued till the oil temperature fall to normal. Then the transformer can be switched on again. Okay, this is the important point for overheating of transformers. Okay, these are the basics details of the transformers. Now, various causes of troubles and failure of core of power transformers. Okay, this is the core. Okay, core. This is the windings. Okay, this is the bushings. Okay, this is the cooling systems. Okay, these holes are controlled cabinet. Okay, tank. Okay, this is tap changing. Okay, in causes of troubles, first, failure in magnetic circuit. Like first is failure of insulation of belt used for clamping core and yoke. If these conditions or these causes is in pictures, the advantages means, first is failure of insulation bolts used for clamping the core and yoke causes heavy circulating short circuit currents, resulting in core heatings. Okay. Next is vibration in core. The loose core clamping bolts and bolts between core and structure results in vibration of core. This result in weak core insulations. Third one is excessive core heating, high magnetizing currents or high interest current. Excessive heating of core result in temperature rise of the winding. Failure of core or bolt insulations. It's moisture absorption and dielectric failure. In overheating of power transformer, melting of core bolts, burning of core bolt, insulation burning of insulation between laminations. Flux density depends on V by F, okay, voltage frequency ratio. The generation transformer fails by overfluxing if excitation maintained during the starting or stopping the unit. Overfluxing relay should be provided for protection generator transformer. This is the classes of different types of trouble failure in magnetic circuit and its remedies. Now, causes of troubles and failure, various types of in power transformer. First is internal fault. Internal fault like incipient fault, overheating, overfluxing, overpressure. And active faults like short circuit in star connected, okay, Y connected windings, short circuit in delta windings, phasor to phase fault, turn to turn fault, and core fault and tango fault. Here, overheating. Now, what is overheating? Overheating caused by overload is failure of cooling systems, high ambient temperature. If overload occurs, they check cooling systems of the transformer. If failure of cooling systems, reduce load on the transformers. If temperature of oil high, switch off the transformer till safe temperature reached. If high ambient temperature occur, if overload problem is occurring for long durations, another transformer in parallel. So overheating is a very weird situations. Okay. Second is sustained higher voltage on primary resulting in overheating of core due to overfluxing. Causes is poor voltage control of power system, use of shunt reactance and tap changing transformer to control busbar voltage within specified limit. The transformer fail due to sustained overvoltage, provide overfluxing protection and overvoltage protection for busbar. Also, flux density depends upon the V by F ratio. Generator transformer gets overflux during the low frequency operations. Third one is external short circuit. External circuit causes by the insufficient clean overhead lines, accumulations of dust of insulation. Okay, so remedies is transformer windings should be capable of withstanding repeated external short circuit without failure and overcurrent protection. Now, next is short circuit between adjacent turns, usually high voltage winding. Its causes is sharp corners on conductors cutting into the insulation, external short circuit, moisture in oil, fluctuating loads, transient overvoltage, etc. Its remarks is Buchholz relay should operate and should alarm. Overcurrent and differential protections should operate and open the circuit breaker. Now, internal short circuit. Internal short circuit occurs the sustained overload and insulation failure, fault in tap changer, failure of end turns of coil due to over voltage surges, bad solder joint causing to local overheating and open circuit, and aging of insulation. Internal short circuit remedies is overcurrent protection, earth fault protection, and differential protections. Now, moisture in oil. Okay, moisture in the oil while filling, breather saturated, defective scales, seals, etc. Oil should be filtered. Silica gel should be replaced. Gaskets should be replaced. Transformer should be dried out. Now next is rapid deterioration of oil should solid insulation. In rapid deterioration of oil, the causes is excessive overloading, presence of moisture, poor quality of the oil, partial discharge, and its remedies is cause should be determined and corrective actions to be taken. Now next is procedure of filling oil in transformers. While filling the oil in transformers, drying out of the transformer tank, core and coils. Filling of oil by means of oil filtering plant. In oil filling, first is don't fill oil from movable tank trailer into the transformer tank directly. Fill the dry oil from mobile tank trailer into the transformer tank via the vacuum filter. Don't fill oil from storage tank into the transformer directly. Fill dry oil from storage tank via the vacuum filter in the transformer tank. Take oil from 200 kg drums into the storage tank or mobile tank trailer and dry the oil by circulation through the vacuum pump, and then the filled into the transformer tank as per the 1 or 2. Okay. Now evacuations, oil filling in circulations, standing time after circulations. It is also main important parts. Before applications of voltage, certain standard time is necessary before applications of the voltages. Next is various steps in commissioning of the power transformers. There are pre-commissioning checks on first is transformer, tap changer bushings, protection systems, control systems, marshalling kiosks, main connections, control connections, cooling systems. In cooling systems, there are commissioning tests, polarity check and phasing, energizing and operation, under observation, polarity check and phasings, loading and observations. Okay, most important steps in commissioning of power transformers. Okay, now testing of transformer oil. First is take the sampling, then containers of samples, oil samples from transformer tank, oil samples from transformer in service, oil samples from drums, testing of direct exchange of the oil, loss tangent and crackle test. Okay, this is also the testing of the transformer oil check methods. Now filtering process and filtering plant for transformer oil filtrations. The oil purifying equipment removes the following from the oil, like a dissolved moisture or free water, solid particles. The oil purifier component is the following components, like a First is vacuum tank and vacuum pump, centrifugal plant, oil pump, heater, valves, temperature gauges, vacuum gauges, pressure gauges, vacuum chamber, strain filter, and streamline purifier. The comparison between the centrifugal type and streamline type purifier. Streamline purifier can remove even fine carbon particles from oil because of the filter press. Centrifugal type of filter removes the moisture and goes more efficiently because oil is preheated and then speed switched. Streamline purifier require specially quality of filter plates. Okay. Now, okay. Thank you.